Because what you, the unsung heroes in the wastewater industry, do matters. Join me, Suzan Chin-Taylor, the DooDoo Diva, a longtime veteran of the wastewater, trenchless, and civil infrastructure industry each week as I deliver industry know-how from industry pros who know how. Whether you want to learn about the latest trends in technology, training and retaining great talent, sales and marketing, leadership and growth, or simply how to be more efficient, productive, or profitable, this podcast is for you. Let's dive in. Well, hello, everybody, and welcome to this week's episode of the DooDoo Divas Smells Like Money podcast. Today, we are visiting with Bob Sweeney, who I'm going to let him give you all of his, acronyms and titles, but he is the president of Environmental Management Systems. And they play a very unique role in the world of on-site wastewater systems, or as most of us, in the layman's world, think of as the septic tank in the backyard. And so welcome to the show, Bob.
Thank you very much, Suzanne.
So tell us a little bit about your background and all the different, certifications you have, and exactly what does Environmental Management Systems do in this segment of the on-site wastewater management community?
Well, I've been involved with public health, safety, and environmental protection ever since I got out of high school.
Oh, wow.
I won't say when.
That's okay.
One fashion or another. But I've been involved with septic systems for 46 years, 20 years as a regulator in Oregon and Washington, and 26 years as president of this company and small environmental engineering firm. And we do everything except for the installation. So we do the site evaluation, the design, the permitting, the inspections, and on long-term performance monitoring, make sure that things are performing as designed and as required by the regulations. And of course, troubleshooting and repairs or connection to public sewer in some cases, if that's required.
Great. Well, because, I have most of my experience in a little bit in the on-site wastewater, but mainly in the municipal or, centralized, public collection systems, treatment plants. And so septic systems or on-site wastewater has it's a completely different animal than a municipal system. And we often hear that term, with contractors and whatnot, and even you mentioned it, cradle to grave on a system. And so tell me what you meant by that as to what your role in, serving the market in those three, I guess you would call it the life cycle of a system that maybe contractors who do installation, or maybe folks that are just, maybe even the pumpers, but what the industry needs to know about the importance of, you had shared with me before we came online, of really pre-planning before you do this, what you're going to have to do to maintain the life of that asset to make sure it doesn't fail. And then if you have to have an exit strategy or replacement, when it's reached its end, what are you going to do? And so kind of take us through that life cycle, if you would.
Absolutely. Well, just taking the on-site wastewater treatment system as an entity, as long as you are generating wastewater, sewage from your facility, you're going to need to have a system, a public sewer or on-site wastewater. We use the term septic because the first tank, the primary tank, is usually a septic tank. The rest of the system is fairly aerobic. And so I don't really like that term, but I can't get away from it because everyone uses it. In some cases, you aerate the tank and you don't have a septic tank. You've got an aeration tank as your primary tank.
Okay.
So you're gonna need to deal with your wastewater, and all water is recycled by nature or by technology. And the technology emulates what nature does naturally. So we have sewage that is created. It goes out the plumbing and out of sight, out of mind for most people's inclination. And
Right.
so it goes out and it either goes to the sewer or it goes to the septic tank. And if it's a gravity septic system, that is a very elegant system, a gravity system. The septic tank is quiet. It goes to a drain field. That's all quiet. Nothing to worry about until something happens. And what's happening in the meantime is your septic tank is filling up with solids. Now the tank is supposed to be full all the time, but if you don't pump it periodically, the materials that don't biodegrade over time will start leaving the tank or clogging the tank and resisting the flow into it. But eventually the material that is supposed to stay in the tank will build up and then start overflowing into the soil. And that's when you're getting into the big expensive systems where you clogged your drain field soil and the piping and the gravel. And now you have to dig things up or replace it. And the typical regulatory means for that is to have a septic system with your initial drain field and a set aside area, put in a new drain field. So we want to prevent that. So part of that is maintaining the system. The gravity system, the biggest thing you can do is check the tank every once in a while. And I recommend annually, but you could probably in most cases get by with checking it every 3 years and determine whether the solids in the septic tank have to be pumped out. And there's a baffle or some kind of a weir that will keep the floaters in the tank, and then the sludge that builds up on the bottom, that has to stay in the tank also. So that middle layer of the clarified zone is what leaves the tank. And that is handled very well with the soil.
So now, as a designer at the beginning of this, in picking like when you were saying having to have that backup site in case the first site should fail, you're hoping that you never have to use that second site. But what happens in those areas where, let's say it's a very small lot? What do you do? I mean, is it always required that you have that, how would you say, that backup? Can you ever build without having an area for the secondary if it fails?
Not usually.
Okay,
it depends.
all right.
If you have an existing lot, there's sometimes grandfather clauses. That may not be a legal term, but there's some allowances for existing lots compared with a brand new lot that you're starting, and everything has to be up to current code.
Right.
Current code is gonna require a full system and then a reserve area for the drain field component that is fully capable of handling that flow. Now, if you have a small lot, then you're often looking at treating the effluent to clear water before it gets to the soil. And that can be done with a sand filter or an equivalent technology. More and more we see aerobic systems or textile filters instead of the gravel and sand systems.
So what have you seen? I mean, we always think of just that. I can't remember her name now, the writer, the grass is always greener over the septic tank. And we always thought of the septic tank. I can't remember her name now. She was a fantastic columnist, but she, that we always kind of were aware that there was one type, but I'm sure, since you've been in the industry for so long, you've seen a lot of advancements in on-site wastewater. What do you think has been one of the most significant and important innovations that is really changing the face of this? Because there's a lot of communities that are going through that push of getting everybody off a septic and either getting them into a public sewer or a vacuum sewer type of system. What do you see could be the alternative to that for on-site wastewater if expense just makes doing something like that completely, it's not feasible?
Well, it's actually usually less expensive to do an on-site system, assuming that you have soil that will handle it. We have all the technology that a public sewer system has that can be done on site now. So most of the systems that we get involved with are not gravity systems. We do have primary treatment tanks and secondary treatment and often tertiary treatment and control panels that have telemetry and will notify us if you're using too much water or if your pumps start using too much energy. that is something that can be programmed in to alert the owner and the maintenance provider that there's something going on there. And if the liquid levels are getting too high, those kinds of things. And then we typically will be, for the types of systems we're dealing with, they're mostly required to have some maintenance. In Oregon and Washington, at least, not all states.
Right.
But most systems these days, the modern systems, we're dealing with smaller lots and less desirable septic fields. So you have a smaller drain field, but the effluent is clear, almost drinking water. And we have the technology to turn it into drinking water. It's just a little much to ask people to drink sewage, even though all water has been pooped in eventually.
Oh, I remember going to a trade show and they were having a competition about beer that was made from treated. It's like, no, that's okay. I'll take your word for it that it's okay. I think I'll pass on that. Thank you very much. I mean, I guess there is still that yuck factor, but it is nice to think that we are all impacting the watershed. Like you were saying earlier, water is recycled so that when it gets finished and it's going into the groundwater, or let's say draining via storm runoff going into the watershed is where we're getting our drinking water. Of course, it's being treated, but the fact that we're not contributing to putting stress on the watershed by having great on-site treatment, that we're not asking Mother Nature to do more than it's really not capable of, but why do we want to stress her out? I just thought that was really interesting when we talked offline about taking into account with your drain field how it's going to impact your stormwater, your groundwater, and what's going to eventually wind up in the watershed. So one thing I wanted to ask you was, since you don't do the installation, how do you work with installers, and how, if somebody is saying, okay, I need a septic system installed, or I need a replacement, how do you come in and help installers, whether it be a new system or a retrofit, to help them provide the best possible solution to that property owner?
Yeah, ideally the installer would be involved in the process at an early stage. Okay. That's not always the case. We try to bring in an installer early, and often an installer will contact us to do the design. So they're extremely valuable in what is practical to do, and what, obviously they are the ones that are going to have to put together the bid on what this particular project's going to cost. We can't say, well, it's only $20 per linear foot of drain field, for instance. That's up to the marketplace. We bring the installer in as early as possible, and sometimes we do the whole siting, design, layout, permitting, and then go to bid at a later stage. And often government projects, for instance, where we're doing a very large system with all the bells and whistles, they go to bidding after the system has already been designed and installed, or not installed, but designed and permitted. And then the installer comes in and says, well, why didn't you use this tank instead of that tank? Or why don't you use a plastic tank instead of a concrete tank? We've gone through the process to do that. We're looking at the various components, and we have a lot of experience with installers and installing, and we design the system with diagrams and photographs of what the installer needs to know in order to install the system. So we're taking into account very seriously how that design is going to be read by the installer and understood. So if we put together a fancy design with lots of verbiage in there and talking about the technology and all that, the installer may not read all that. They want to look at the pictures and the bullet points, what what has to be done. And they do a great job. The ones we work with. Occasionally we'll get an installer that doesn't have the experience on a more complicated system. Then we have to spend more time on that. And so we do construction management to the extent that is needed. In most cases, when we inspect a system, we're inspecting in 2 or 3 points during the construction of the system, and then we will come back after about 30 days after the system goes online to make sure everything is still working. Normally, we would have some alarms if something happens. Let's say a pipe was not glued together properly. That can happen.
Right.
And so in that 30 days, that's when something like that is likely to happen, or a manufacturer's problem. We've had some manufacturers that have had glitches that cause problems.
Right.
And we try to use the best manufacturers, and sometimes people try to get the least expensive, and that may or may not pan out.
Well, that all comes down to that, you get what you pay for, and you may be saving some money now, but you may regret it 10 years from now, or it's going to cost you a lot more. So the way I'm hearing it, or what I'm hearing in the advantages of working with a firm such as yourself because of your experience, is having a great design up front that ensures that you're doing the best, you're choosing the best technology, you're choosing the best location, you're choosing the best, how are you going to configure this for the asset life.
Correct.
And then also to save work later on.
Correct. And often the best place for the septic system is the best place for the view of the mountain. So we're not always dealing with most advantageous drain field location. And then we deal with other systems such as drip irrigation. I really like to do that whenever possible. It's not in Washington. It's a system that we can use at the local level. In Oregon, it's not on the list of approved devices, so we have to go through a state permit to get drip irrigation involved. And that's when you're using the landscape and more creatively.
So tell me about this drip irrigation and how that ties in with, you were saying when it's a mountain and working with the landscape and you like to do that. Tell me exactly how that works.
Well, unlike a trench system or a bottomless sand filter or a sand mound, drip irrigation doesn't have gravel. You're inserting it into the soil, typically at 6 to 10 inches, maybe 12 inches into the soil, and it's a 1/2-inch flexible pipe most of the time. There are some larger versions for bigger, but it comes from agriculture. It's been around in agriculture for 30 years, and it drips into the soil, and then you have the capillary action that goes into the soil in the root zone, and that absorbs and uses the nutrients, nitrogen and so forth, and the water for the plants. And and these drip lines are usually 1 to 2 feet apart, and the emitters themselves are basically places where there's a device that causes some turbulent flow. So the emitters all allow the water to deliver to the soil in a manner that the soil can just use capillary action to move it in all directions and not just down. So most systems, a gravity system in particular, the sewage will go down the first few holes until that biomat trench starts to build up, and then it'll equalize throughout the trench. But in a drip system, you're irrigating the whole system at the same time, no saturated flow, and these lines can go up and down quite a bit, so that you don't have to be as flat as you would with a trench system.
Now I see why you like it so much. It's a much better design if you can put it in.
And you don't have to use potable water. You can use just septic tank effluent in some cases.
Oh, interesting.
There's some, it's more reliable for the drip system if you use a sand filter or a textile filter aerobic device before the drip field. But the drip field can be done with septic tank effluent and an automatic flushing mechanism built in. So it's a more complicated system, and like anything else that is complicated, you're going to have a little bit more maintenance involved, but you're dealing with something that can really be used in the landscaping.
Oh, wow. Okay. All right. I like that.
And if necessary, we disinfect with ultraviolet disinfection, those kinds of things.
So, Bob, in just wrapping up, if you were to share with us your words of wisdom as having been in this industry for so long, of things to consider in regards to, working with a design firm, working with a consultancy such as yours, what would it be to your peers in the industry?
Well, we should be involved early, because what we need to do is deconflict all of the potential needs of the facility and the site. So you're designing your system for the receiving environment, but so are the people that are dealing with drainage from the roof, the stormwater from the parking lot, people that are trying to protect the wetlands, so the erosion control folks, and those are typically silos of different regulatory entities that may or may not talk to each other. So we put it all together. So we do not only the septic system, but we're looking for the site stability. Is this site, does it have geologic issues? Is it likely to slide down the hill? Sometimes you have to get a special report done on that. Is it too wet? Yeah. Is it a wetland? And can you use that? Actually, the wetland likes having water and nutrients, but you can't have open sewage going into a wetland. And if your lot is too small, then you have to have a higher level of treatment. And if you don't meet the codes, and one of the biggest things I see is we have a set of prescriptive codes that is good most of the time. It works most of the time. It's been developed over the years, trial and error, but it's not science. If you go to a performance-based system, then you're looking at more information about the site, the vegetation and the soils and the underlying geology, the slope, and all those things come into play in order to best utilize that site and get the most bang for the buck and protect the environment. So we about 25% plus or minus of the nation is on septic systems, and that's not changing. I mean, it's not diminishing. More and more people are going on septic. I'm on the board for the National Onsite Wastewater Recycling Association, and we're really pushing for reuse. We have the technology to use that effluent on site, treat it, return it to nature, as opposed to a centralized system where that has to flow miles to a centralized facility. And then even if you clean it up there, the centralized facility doesn't have any need for that water. So it's designed to dump it into the lake or the ocean or the river or the groundwater. It would be extremely expensive to take an existing sewer plant and pump back to the neighborhoods. Well, we have the technology. We don't need to do that anymore in many cases. So, wow. And you look at Japan and some of these places where it's very densely populated, they have buildings that treat their wastewater on site, treat and reuse the wastewater.
Right.
There's no wastewater. Nature doesn't know anything about waste. Everything is just fine to nature. something like whatever you're discharging.
Yeah, something out there will find a food source. It's, the great, I guess you call it the great circle of life. So, Bob, thank you for sharing your insights and also giving me a little bit of an education and thinking about, I never really thought about septic as being that complex and all of the things that you would need to take into account before installing a system. And there's a lot of science, there's a lot of engineering and physics and hydrology and everything that goes into this that I think a lot of people, especially consumers, never really think about. We think of that as something that is complex down at the wastewater treatment plant, but not just, okay, it's a septic tank. How complex can it be? And so this has been very, very enlightening, especially all the things when you were saying about the roof drainage and the driveway drainage and all those things that in a site have to be taken into account. And so thank you for sharing that with me and our audience. And again, thank you for coming onto the show and for you tuning in. Thank you for listening today. And I hope you got something out of this and maybe learned something new about on-site wastewater systems that you never knew before. And so until next time, thanks again and keep it flowing.
Be sure to subscribe to the show so you'll never miss an episode. If you're an industry expert and would like to be considered as a guest on the show, click the Be a Podcast guest link below in the show notes for more information. Thanks again for joining me, the DooDoo Diva, on this week's episode of the Smells Like Money podcast.